Ma'am, shall we start the session, ma'am? Dear participants, we are going to start our next session, which is going to handle by Dr. Jaishankar Natarajan. He is going to handle the topic supervised learning and unsupervised learning. Dr. N. Jaishankar is a professor in the School of Computer Science and Engineering at Vellore Institute of Technology, Vellore, India. He was program head for MTech CSE program and division head for Computer Network Division. He received his BE Computer Science and Engineering from Bharatiyar University and ME Computer Science and Engineering from MK University and PhD Computer Science and Engineering from VIT University. When coming to his experience, he has 25 years of experience in teaching and research. He received certification for CCNA instructor and Sun certified Java instructor. He has reviewed many books titled Network Security, Data Mining, TCP IP Protocol Suite, and Programming in Java. He has participated as a coach in international programming contest held at IIT Kanpur, India. He has worked in Neosoft Institute, China. When it comes to his publications, he has published many papers in international and national journals and conferences on network security, computer networks, and data mining. His research interest includes computer networks, AI and machine learning, network security, cloud computing, data mining. He has served in many peer-reviewed international journals as an editorial board member, guest handling editor, advisory board member, and reviewer, etc. Also, he has served in many international conferences as general chair, international advisory board member, technical program committee member, publication chair, organizing committee member, reviewer, etc. He is also a life member of Indian Society for Technical Education, Computer Society of India, International Association of Computer Science and Information Technology, International Society for Research in Science and Technology, and member of International Association of Engineers. We welcome you, sir.
Sir, we are not able to hear you.
Am I audible now?
Your voice is breaking, sir.
One second. One second.
Sir, your voice is breaking. You please disconnect and join back to the session again.
Okay. Am I audible now?
Sir, you have connected through two devices. That's why it is getting echo is coming. You put the other system in mute.
One second. Now it's audible?
Yes, sir. Now it's audible.
Okay. My screen is visible?
It's not coming. Have you presented your screen, sir?
Yes, ma'am. But the share is not. One second.
Balakrishnan, are you there? Bhargav,
Yes, ma'am. Yes, ma'am.
you stopped recording and started back again.
Sure, ma'am. Sure, ma'am.
Am I audible?
Yes, sir. Now you are audible.
Yeah. Please check my screen. Is it
Yes,
visible now?
yes, sir. It's visible.
Okay. So good morning. Good morning to all. So I'm Jai Shankar, working as a professor in School of Computer Science. So today my topic is supervised and unsupervised learning. So before discussing my topics, I like to give some introduction about the data science. So we know that data science has become the most demanding job of the 21st century. So what is a data science? Data science is a deep study of the massive amount of data, which involves extracting meaningful insights from raw, structured, and unstructured data that is processed using scientific method, different technologies, and different algorithms. So we know that it is a multidisciplinary field. So nowadays, the data science is extensively used by the companies like Amazon, Netflix, and healthcare industries in the field of fraud detection, internet search, and airlines, etc. So it is a multidisciplinary research. So in that, if you are taking the data science, machine learning is one of the important component. It's a backbone of the data science, right? So in machine learning, so there are different types of learning we have. Supervised learning, unsupervised learning, and reinforcement learning. Okay, so we'll discuss about the supervised learning and unsupervised learning in the particular part of the data science field. So if you are taking the data science, that is the data science supervised learning. Okay, so we are giving the input, right? Using the algorithm, we have to train the data. We'll get some patterns. That is what that we call as a training. Okay, so after that we give the new data, that is called the test data. We call it as a test data. In the patterns, we'll give the output, that is we call the testing part. There are two types of parts in the supervised learning, training part, and another one is a testing part. So we know that supervised learning is a name indicates the presence of the supervisor or teacher. Okay. So in this example, right, in supervised learning, we have the input data as well as we have the output data. For example, so in this loan application data, so these are the input data, right? Age, has a job, whether the customer has a job or not, whether he is having the own house, whether he has a good credit rating, okay, or excellent credit rating. Okay, based on this input, right, whether the customer is approved a loan or not. Okay, this is we called as a class label. This is the output variable. This class label we called as a output variable. Okay. So in the supervised learning, we know the input data as well as we know the output data. The class label we called as the output data. So we have to give the input data and output data. We have to train. Okay, we have to give the training in the system, train the machines. After that, if you want to give the new sample, right, whether we can decide that whether the loan can be approved or not. Okay, that is the main bit here, the supervised learning. here in supervised learning, we have the labeled data, right? We have the input data as well as the labeled data. So I'll give the introduction about the supervised and unsupervised learning. Okay, then I'll discuss the algorithm one by one. Okay, this is supervised learning. We have to load the labeled input data. We have to train the model, and we'll get some patterns. Based on this, we'll give some new data and test the outputs. See, for instance, suppose you are given the basket filled with the different kinds of fruits. Okay. So if you have to train, we have to give the training to the machine. If the shape of the object is round, right, and depression at the top having the color red, then we can label it as a apple. Okay. If the shape of the object is long curving cylinder having color green or yellow, then it is labeled as a banana. Okay. So we have to train, we have to give the features, then we have to give the training to the machine. Once trained, then we can give the new data and we can test it. Suppose you are giving the banana, right? The machine is able to tell that it is a banana. Say example applications, for example, in emergency room in a hospital measures 17 variables. For example, blood pressure, age, okay, and so on, for the newly admitted patients. So you have to take a decision that whether it is a high risk patients or low risk patients. We have to classify. Okay, the supervised learning mainly depends on the two things: regression, that is called a prediction. Another one is a classification. Okay, we have to classify into high risk patients or low risk patients. Okay, then only if it is a high risk patient, we can give it to the ICU. Okay, similarly, the credit cards company has to decide whether the loan has to approved for the new customers or not, based on the past history, right? They're collecting all the parameters: age, marital status, annual salary, outstanding debits, credit rating. They collect all the parameters, all the inputs, and analyze. So we have to train from the past experience, then train the model. You'll get the feature, right? Then give the new data, test the output. This is the main objective of the supervised learning. There are two things are involved here: learning, another one is a training. Okay, learning, other name we call it as a training. Okay, another one is a testing. Okay, the two things are involved in the supervised learning. So first, learn a classification model from the data. Okay, for example, in this example, whether for the new customer, whether we are going to give the loan or not, whether we have to approve the loan or not. See here, this is we call it as a class sample. Okay, or testing sample. We call this here. So age group, age is young. There is no job, right? There is no house. Okay, so some has some money. Good credit, some credit rating is good. Okay, whether we can, the manager has to decide, right, whether they can give the loan or not. Okay, so for new customers, based on the previous customers' past experience, the manager can decide that whether he can give the loan or not. So in the supervised learning, class label is known. Okay, class, we have the input data and we know the output data. Class label is known. Whereas in the unsupervised data, the class label is unknown. Okay, class labels of data are unknown. We can take the examples of clustering. Clustering is the example. As I said, there are two steps in the supervised learning process. Okay, so we call it a learning step, or we call it, sometimes we call training step. Okay, so learn the model using the training data. Okay, if you have the data, 100% data, we are divided into two parts. Okay, for example, 70% of data we consider as a training data, remaining 30% data we consider as a test data. Okay, so first we have to train the model. Okay, so after that we have to test the new data, 30% data, right? We have to test whether it's working correctly or not, whether your model predict the data accurately or not. Okay, how do you calculate the accuracy? Okay, so number of correct classification divided by total number of test cases. So based on this formula, we can calculate the accuracy. These are two steps in this algorithm. So classification problem, right? The classification, the two types of algorithm we have: classification algorithm, another one is the regression algorithms. Okay, so classification, as I told you earlier, we can give it in the category. This based the output variable is depends on the categorical attribute, whereas the regression the output depends on the continuous attribute or the real values. Okay, whether the dollar or weight is a numbers, continuous variables. Okay, so regression is based on the continuous variable. Classifications the output will depends on the category, whether it's a red or blue, whether disease are there or not. There is no disease like that. Okay, so in the supervised learning, right, the classification is based on the labels, right? Labels there. In the regression, there is no labels defined. As I told, it depends on the discrete value or category value, right? Then regression problem responds for the continuous data. So suppose if you want to predict the stock market data after 10 years, okay, based on the past history, we can predict. So in this situation, we can use the regression problem. For example, we can take another examples also. We can predict the housing prices based on the past history. After 10 years, what is the housing price for the square feet for the particular area? We can analyze all the parameters using the regression techniques. Okay. So regression, another one is a classification. Classification, we have many algorithms. We have a naive-based classifier, decision tree algorithms, support, shortly we call it SVM, right? So today I'm going to discuss the naive-based in classifier, the regression problem, naive-based in classifier, and the next one is in the clustering unsupervised learning association, a priori algorithm I'm going to discuss today. So unsupervised learning, right? We have to give the training without guidance, right? Without guidance, we have to train. Okay. So here the task of machine is to group unsorted information according to the similarities, patterns, differences without any prior training of data. Okay. So you are giving the input data based on the similarities, patterns, differences. It will group into separate categories. So suppose the image is given, dog images and cat images are given here. Okay. So assume that is a child want to categorize these images. Okay. So so machine like a child only, we have to give the training. There is no idea about the features of the dogs and cats. Okay, we cannot categorize it into dogs or cats. Okay, but it can categorize according to the similarities, patterns, and differences. So for first group images, we have the dogs, we can cluster it, and second group of images we can categorize into cats, like that. There is no class label is involved here. Okay, so in unsupervised learning, we can say the example clustering, there is no class label is involved. The main thing is in supervised learning, class label is involved. That means we have the input variables and output variables. Whereas in unsupervised learning, there is no label. It's unlabeled data. So clustering is one of the example for the unsupervised learning. Okay, another one is an example for the unsupervised learning association. Okay, so if you are taking the supermarket, right, we can analyze the manager will analyze that what are the items purchased together. Okay, in that case they can use the association rule mining. There are different types of algorithm we have in the clustering, hierarchical clustering, k-means clustering, right? The principal component analysis, lot of algorithms we have. Okay. So what is the difference between the supervised learning and unsupervised learning? In the supervised learning, input and output variables are given, whereas in the unsupervised learning, only the input data is given. Okay. So another important difference is you can use the supervised learning, you can use the offline analysis, whereas the unsupervised learning you can use the real-time analysis. As I said earlier, in the supervised learning, the output is predicted using the labeled input data set. Okay. So here in the unsupervised learning, the output is predicted based on the patterns in the input data set. So the main algorithm in the clustering part is a k-means algorithm. The k is a number of clusters. For example, take the Amazon is example. Okay, a lot of items are grouped together. The clothes item, TV items, right? You have seen the Amazon or a Flipkart, right? So particular items are grouped together, right? So if it is a hierarchy means, so under the TV again we have the some different groups. Okay, for example, if electronics groups, so we have the TV, then other electronics appliances we have. There are different groups. We have the different hierarchy. Okay, that is we call this a hierarchical clustering. Okay, so in the k-means algorithm, first we have to select the k data points After that, we have to compute the clusters centroids. Okay. Then we have to find out the optimum centroid. Okay. So we have to calculate the sum of squared distance between the data points and the centroids. Okay. Then assign each data point to the cluster that is closer to the cluster. So this is an algorithm, but I am going to discuss linear regression in detail. Okay, then the classification part, navigation classification. I take this a lot of algorithms are there. The one of we cannot complete. Okay, another association rule meaning a priori algorithm I'm going to complete. Okay. So the game means algorithm normally used for market segmentation, document clustering, image segmentation, image compression. For the purpose we can use. So now I'm going to discuss about the supervised learning algorithm.
Sir, I have a question.
Yes, yes.
Yeah, how will you differentiate between a model and an algorithm?
Which one? Model. So the model we call this algorithm, right? List of steps, right?
Okay, so model and
Now,
algorithms are
one second, I'll explain that. We have the training data, right? We have the data, right? So we have to give the input to the algorithm, right? So we have to train the model. Okay, we'll get some output, right?
Right.
See, we'll get some output. That output we called as a pattern.
Okay.
Okay, that output we called as a pattern. Okay, next time if you want to give the new data, new samples, you take that patterns, right? Give the input as test data, we'll get the output.
Okay, thank you, sir.
Okay, in detail I'll discuss. Don't worry about that. Okay, in detail I'll discuss. Everybody's having the Anaconda I've installed.
Yes, sir.
So participants, have you installed the Anaconda?
Yes, sir.
Okay, then I'll go to the hands-on also, right? So linear regression, I'll give you some introduction. Okay, it is one of the supervised learning techniques. Okay, it is used to relationship between the two variables. For example, based on the year of experience and salary, we consider two variables. So for year of experience increases, salary also increases, right? Okay, so if it is a relationship two variables, we can go for the linear regression. Okay, there are three types of correlations. It is a positive correlation, right? That none of them is a negative correlation, and third one is a no correlation. It is a positive regression, negative is a negative regression, third one is a no correlation. Okay. So if the x increases, this is a x variable, this is a y variable. So x is we call this a independent variable, y we call this a dependent variable. Okay. So we have the data points. So I hope you know that we have the take the example year of experience and salary data, right? So we plot the points here, right? Then we plot the that is a straight line. Okay. So this is a line of regression. I'll explain in detail about that. This is the overall view. Okay. X is the independent variable, y is the dependent variable. Okay. If it is a positive correlation, that if it is a positive correlation means if the x value increases, y also increases. If the x increases, y value also increases. In that case, we call this a positive correlation. If it is a negative correlation means the x increases, y value will be decreases. Another one, a no correlation means if x increases, y will not increase. This is a straight line like this. It's a straight. It's not mentioned in the figure. Okay, it is a straight line like this. Okay. So, what is the formula for calculating this linear regression? Any idea? Y equal to mx plus c, right? So we know that y equal to mx plus c, or we can say that y equal to, in a convenience, I'll take this y equal to c plus bx. Okay. So y is the output variable. Y is the output variable. We call this independent variable. Okay. Sorry, y is a dependent variable. C is a constant. Here b or m we call this a slope, right? Or sometimes we call this a coefficient. X is a independent variable, okay, or input variable. This is the input variable, this is the output variable. Okay, the input variable we called as an independent variable, output variable called as a dependent variable. So we know the formula, we take the formula Fahrenheit equal to 32 plus 9 by
Excuse
5.
me, sir.
Yes, yes.
Hello.
Yeah.
Sir, in the previous, just a moments ago, you were discussing about negative correlation. So, can you please go back to that particular graph?
Yeah.
Yes, so in this equation for line, it says y is equal to minus a0 plus a1x. So, how can the intercept be negative? So, with
No, I'm
increasing
telling
x,
that, okay, if the X value increases, okay, Y value will be decrease.
so
Okay,
shouldn't it a0 minus a1x
A0, no, don't
minus
consider this,
a1?
I'll discuss in detail about that. Okay, don't consider that. The concept here is, right, if the X value increases, Y value will be decrease. Okay, in detail I'll discuss. Okay, so F equal to 32 plus 9 by 5, right, into Celsius. Okay, so take this example. So here Fahrenheit is the Y, right? So see 32 is a constant, right? And 9 by 5 is the B value. Okay, then X. Celsius is the X value. Like that you can calculate. Okay. Another one is, so we have to calculate the slope, right? And coefficient. Okay, slope and coefficient. So we have to intercepting the point of the slope with the Y coordinate. Okay, intercepting, suppose we are taking this one, right? So we are drawing, if intercepting the point, slope point, right, with the Y coordinate, this point we call as a C. I don't want to discuss more mathematical concepts. Okay, so intercepting points here we call it as a C, right? So suppose we take the salary and experience data set. Okay, if the experience increases, salary also increases. Okay, so we plot the points, then we plot the straight line. Okay, so in this straight line, so what are the points in here touching the Y coordinate? That is the C equal to 0. Okay, what is the meaning of this? This is starting salary, right? We call this a starting salary. Okay. So how do you calculate the this slope, right? We know that, okay, suppose you take the 2 points, so we take the 2 points, so this is x1, okay, so this is y1, we take this is this is x2, another point is the y2. Okay, so if you take the slope m or b, right, what is the formula? Y2 minus y1 divided by x2 minus x1. Okay, this is a formula for calculating the slope. And constant means that is C, extending the slope line, right, till intersecting the Y. Okay, this point is a constant part. Okay, so how do you find best fitted slope? Okay, the best fitted slope means with the minimum deviation, or we are having the minimum error. Okay, so we can draw the graph in any way, right? We can draw the graph in different ways. So for example, we have the data like this, right? Either I can draw the straight line like in this way, or we can start from here or start from here, right? So how do you identify which one is the best fitted curve slope? Okay, so we have the formula for that, right? To calculate the best fitted slope. For example, we have the graph like this. This is experience. This is a salary, right? So we have the we plot the graph. Okay. So we plot the straight lines, right? So take the this assume that this is the actual data point. This is the actual data point. This is the predicted one. Okay. This is the predicted data points, right? So we have to calculate the deviations, right, between these 2 points. So put the straight line here, this point is touching in this we call this a y1, this is actual, right? So I'm extending these points here on the y side. Okay, this is a y1 cap. Okay, this is y1 cap, right? So the error will be what is it? This is a deviation part, right? This is a deviation part. The error will be actual minus predicted. Okay, the actual minus predicted. Okay, actual is the y1, right, minus y1 cap, right? So we have to calculate the sum of squared error, right? So sum of I equal to 0 to n y1 minus y1 cap whole square. Okay, we have to calculate. Okay, the best fitted slope is the minimum value of sum of squared error. Okay, machine learning algorithm calculate the sum of squared error for all the points, right? Which point has the minimum deviation, that point will be considered for the best fitted slope. Okay. So another thing, we can take the data set. So if you have the this one spider, everybody have anaconda? Can you open the spider, please? So kindly open the spider. Actually, I have the data set. I take this salary data set. Year of experience and salary. This is my data set. Okay. So you can download from the net also. The sample data sets are available. So here you set as a working directory, change the working directory here. Change the working directory. Okay. So first step, we have to import the libraries. There are different types of libraries in the Python, right? Used for data science. The main data that's library is pandas to handle the data set. Okay. So another one is we can use a NumPy library. If you want to calculate there's a use for the algebraic calculations we can use. Then matplotlib, LIB, okay, used for visualization purpose. Can use that. So you have to import libraries. Import pandas as PD. Import. This is for pandas for handle the data set. Okay. Another NumPy as NP. This is a alias variable. NumPy for arithmetic calculations. Or if you want to convert into array, you handle the array, you can use it. Import matplotlib dot pyplot as PLT. You can give the another name here. Okay. So if you want to execute this, you can select this, then press Shift Enter. Okay. This is the console window. This is the control here. This is a console window. There is no error here. Okay, there is no error here, right? So if you want the spider, right, the spider, if you want to execute the complete program, also we can execute, or if you want to execute the program partly also, we can execute. We have to import the libraries. Then we have to import the data set. Next step, we have to import the data set. So data set equal to td dot read underscore CSV. I stored as a CSV file, and file name is salary hyphen data. I check once. The file name is this one. This is my file, salary underscore data. Okay. So if you want to execute this one, select this and shift. So the reason is we have to select as a set console as a working directory here. not working. So actually, instead of typing one by one, I wait and have some data set.
Excuse me, sir. I have one question.
Yeah.
Can you please repeat how we can import whether we have to store the data set in the Google Drive?
No. Actually, the two ways we can do the program. If you want to use the Google Colabs, we have to store.
Yeah.
Right. I'm using the Anaconda.
Okay.
That's why I told you initially whether you install Anaconda or not. I installed Anaconda software here. Okay. See, if you are installing Anaconda, Jupyter also there, Spider also there. Okay. Supports the Python. Okay. I stored the data set in the same directory. See here. This is it visible? Simple linear regression. I stored.
Yeah.
Here
Yeah.
I stored the data set here. Under the directory, I stored the data set. Okay. If you have to store the Python file also in the same directory.
Okay. Okay, sir. Thank you, sir.
So typing is takes like time. That's why I copy this. So here, one second, I'll execute and yeah. Here, please note on that in the console part, we have the variable explorer, right? We have the variable explorer, right? So in the variable explorer, see here, we have the X and Y, right? This is a row and column is mentioned here, right? See here, data set PD dot PD means the pandas, right? Read underscore CSV. I use the salary underscore data dot CSV file. Already I showed you. This is my data set. I have to read that. Okay. So then I have to store what is X value, what is the Y value. So I consider this is X value. Year of experience is X value, right? Salary is a Y value, right? How to extract that? If you know the Python, you know that. So I want all the rows. I LOC, right? I location. Okay, use it to extract the data based on the index location, right? I log is used to extract the data based on the index location, right? So I want the x-axis. I want all the rows. See here. That's why I didn't give anything. I want all the rows. Colon, right? Then comma. Then here column value. Okay, this is column value. So either you can use 0 to -1 means if you know the Python, -1 means last but before, right? Either you can give -1, right? Or you can use the 0:1 also we can use. Both are valid. Okay. So I'm extracting last bit before the value considers here XS. That means this value. This value. Year of experience I consider here X value. And the one index, the first index. Okay, all the rows and column is the first index is considered as a Y value, Y coordinate. Okay, so can you tell me why you are using the dot values? Any idea? Why you are using the dot values? If you are using the dot values, the values or X values are converted into array. See here, X value is converted into array, right? The X value is converted into array. Another thing, another set of instructions.
Sir, can you come again on x equal to dataset dot I log colon 0 colon -1?
Yes, I repeat once again. You know the Python concept? Python?
Yes, sir.
You know Python?
-1 is -1 is used to take read the data from the
meaning of -1 in the last but before, right?
Yes.
Yeah. So
the last element, the last one or second last element, sir?
Yeah, last but before here. This one is a last before that.
Okay, right, sir.
Okay. So I take I extract this value. So we can use the different techniques. I use this one. If you want to 0:1 also, that is correct, right? Is it clear?
Yes, sir.
Okay. Another one, we have to split the data set, right? We have to split the data set into two parts. I told you training data and testing data, right? So training data and testing data. Suppose we have assume that this is a data set, right? So 70% of data I consider as a training, right? Remaining 30% I can consider as a test data, right? So I plot the curve here like this. So I have the data set like this. I have the data set, year of experience and salary, right? So 70% of data I consider as a test data. 30% I consider as, 70% I consider as training data. 30% I consider as a test data, right? So here, so this is a X train. This is a X train. This is a X train. This is a Y train. Please listen carefully. This is a X train. This is a Y train. Okay. This is a X test. This is a Y test. I consider this is the training data set. Okay. Is it clear? This is the whole data set. I divide 70% of data considers a training data set. 30% of data considers a test data set. Okay. So I consider this as a X train and Y train. Here X test and Y test. Okay. See here, we have to split the data set into train and test data. So in this, in the Python, we have the sklearn library. Okay, we have the sklearn library, right? So what we are doing here? So here from sklearn model selection, this is a keyword we have to use, right? This keyword you have to use. Then import train test data split. Okay, these are keywords, right? So if you want to help, right, place the cursor here plus control I. Here, if you place the cursor here, right, or just place like this. Okay, or if you want to get the command in the console window, control I. You have to use the control I to get the help, right? To get the help, right? So the split is available in the sklearn library. We have to import train test split. We have to import the train test split. Okay. So see here, I told the diagram X train, right, Y train, X test, Y test. Okay. So 70% of data is the training data. There is a X train data, and this is a year of experience. This is a salary, right? See here, X underscore train, then X test, Y train, Y test. Okay. So you have to give them this order, right? Then you have to use the train test split, right? You have to use the X value. What is X value here? What is X value here?
Column A.
Year of experience, right? What is the Y axis value? What is the Y axis? Salary. Yeah. Okay. So here we have to give the test size. Okay, I told in the example, right? 70% of the data is considered as a training data, right? 30% of data consists of test data. So what is the meaning of this? 70%, I take the 70% of data, I have to give that training the machine, right? So we train that machine and we'll get some output, right? After that, the 30% data I am testing whether our model is correctly predicted or not. Okay, some participants asked me what is a model. Okay, so after training, right, we'll get some patterns, right? That we call this a model, right? So the meaning here, test size 30 means 0.030 means 70% is training data, 30% is testing data. The meaning here, we are giving the testing size only here. Okay. So the meaning, implicit meaning is 70% training data, 30%. If you want 80%, 20% means here you make it as 20. Okay. Another parameter, random state equal to 0. What is the meaning of this? Suppose if I'm not given this variable, what will happen? 70-30 proportion. Okay, this is my data set. This is my data set. 70% of data, right, is considered randomly. Okay, while running the first program, okay, first 70% will take as a training data, remaining 30% test data. Well, next run differently, last 70% will take the test data and remaining the first 30% consider test data, like that. Okay, randomly will take. Okay, to avoid this, if you're taking the test size differently, what will happen? What will happen? So every run will get a different output. For every run, we'll get the different output, right? If you're taking the test, the random state equal to 1, okay, every time we'll get the different output. 70-30 proportion will not be same for all the run. Okay, if you want to keep the 70-30 fixed for all the run, right, we can use random state equal to 0, right? Any doubt on this? If not given random 0, I mentioned here, in the next run, it will split into data into different values. We'll get the different outputs. Right? So any doubts in this part?
If we put random underscore state equal to 2, then what will happen?
No, I'm telling you, if you are giving any value or omitted every time, right, it will split into different category.
Okay, thank you.
Sir, suppose we want for k is equal to 5-fold, something like that. Can we
Which k value, ma'am?
K is equal
Which
to
k?
5 or 5-fold validation?
No. So this
Test
is for the
size,
regression concept.
Okay, sir. Test size is here 30. 70% is used for training and 30 is for testing, right?
Yeah.
I want to test all the data like 5-fold, 80-20. The 80-20 can
And
be.
how do you test, ma'am? How will you test?
நீங்க 80-20 போடுறீங்கன்னு வச்சுக்கோங்க. 70-30க்கு பதிலா 80-20 போடுறேன். ஆனா அது வந்து 5-fold validation. 20-20-20 நான் சேஞ்ச் பண்ணி நான் வந்து ட்ரைனிங் கொடுக்கலாம்.
Okay.
K-fold validation சொல்லிட்டு இருக்குல்ல சார். அது வந்து அந்த கான்செப்ட் வந்து இங்க வந்து நீங்க எப்படி இன்கார்பரேட் பண்ணலாம்னு கேக்குறேன். இங்க வந்து நீங்க சொல்றது ஓகே, நான் அண்டர்ஸ்டாண்ட் பண்ணிட்டேன்.
Here we can split like this only.
இது மட்டும் தான் பண்ண முடியும். ஓகே,
அதான் பண்ண முடியும்.
என்ன போட்டா என்ன ஆகும்? வேற என்ன வேல்யூஸ்லாம் ரேண்டம்ல வந்து என்ன வேல்யூ?
Kindly speak in English so that we can also understand the question.
If the random set is giving other value, right? If the random set is giving, we know that what is the value for true or false in C, ma'am?
0 or 1.
No, it's wrong. Value for 0 represents false. You can give any non-zero value considered as a true.
Any non-zero value, anything can be. Okay.
Any non-zero value is considered as true.
I can even put 100 or something like that.
Yeah. Any non-zero value in programming language
is considered as false.
Yeah. Any non-zero value considered as any non-zero value considered as a true. You can give the one. Not we studied like this only 1, 2, 1 only. But practically, if you give the 100, that is also true only.
0 or 1. For 1, we can replace it by any other value.
Yeah, any randomly will split. Randomly will split. Okay. Right. Next part, we have to build the model. We have to build the model. Okay. So to build the model, right? So we are using the linear regression. Actually, if you are using the Python, all the algorithms are very easy, right? So all the models are available in the sklearn library, right? If it is a linear regression or navigation classification or a priori algorithm, right? So all the algorithms are given in the sklearn library, right? If you want to build the model for the linear regression, right? You have to use this sklearn. Okay, from sklearn.linear model, we have to import the linear regression. We have to import the linear regression. Okay, Then create the object for the class linear regression. Right. Next step, we have to create the object for the linear regression. Okay. Then regress dot this object dot fit. Okay, we know that if in the object oriented programming, if you want to call many method, we have to use the object dot method name, right? So I'm giving the X train and Y train. So I told you this part, X train and Y train. So this part, this is a training part, right? So you have to give here, right? This means I'm training my model. This step for training. I'm training my model. Training my model. So if you want to execute, select this, and shift enter. Okay. So what is the error here? Okay, we should not use this command line like C or C++. Actually, had use. Okay. Shift enter. Okay. So there is no error here. Okay, I'm using the shift enter here. There is no error here. Okay. So is it clear, ma'am? Any doubts? This is for training purpose. This is for training purpose. If you want to select any variable here, we can. What is the X states here? We have used, right? Training is 70%. Testing split it automatically. See here, the variable here split it automatically. What is the X value? What is the X test value? See here, it's split it like this. 70-30 composition, right? X train data, Y test, Y train. Automatically, we can check here in the variable explorer, right? You can check in the variable explorer. Right? After that, we have to predict. I told you we have to train the model. After that, we have to test. There are two steps are involved in the algorithm. Next step, we have to predict. Okay. So regress is an object name. .predicts method is available in Python. Okay. So predict X test, testing data. In this example, I take this test. Okay, testing data. Okay. So I'm testing here. So I can run here. Check the Y test and Y predict data also. Shift enter. Okay, it's run perfectly. See here in the console window. If it is error, it will show the error here in the console window. Okay. There is no error here. Okay, we can predict the values. After predict the values, okay, what you have to do? There's no error, successfully executed in the console. Okay, we can check the variable explorer. Okay, variable explorer Y predict. You double click this. You double click this, you'll get the data set here. Okay, this is a prediction value. It's a predicted value. So if you want to test, if you want to see any data value, we can double click this, right? We'll get the data value, right? So you get the Y prediction and Y test. It's almost same. This is the value here. This is the Y test and Y prediction. See here. It's not exactly same. So closely it is same.
Hello, sir. Can we put confidence interval on this so that we can check whether the values are matches with the given confidence? Can we put confidence interval?
No. It is it's an algorithm. Okay, the predict command, right? Will predict everything, right? So there is a, if you want to write the code, we have to write the code.
Yeah, I understood your point. Actually, if we predict the point estimate, that exact value, the actual value and the predict value, probably they will not match.
I'm showing,
But
wait for some time.
Professor,
wait for some time. Professor, wait for some time. I'll answer your query. Right. Next step, I'm giving the visual representation also. Then look into this and ask the question. Right. So if you want to visualize the output, right? Right. So if you want to visualize the output, right? The plot, if you want visualization, I told you matplotlib you have to use. For a visualization purpose, you have to use the library matplotlib. I use the PLT here. I use the PLT here. So if you want to give the title, right, you can give the title here, right? Suppose I am not using this output, right? Scattered, right? So plot, if you want to give the title, right? What is the X label you can give, and Y label also you can give. Yes. Yes, ma'am.
Scatterum vachu panunga.
It's not clear, ma'am. What you are telling?
Can you keep the scatter as well, sir, for plotting?
Yeah. I'll give, ma'am. First, I'll run this and show the scatter also. Okay, I'll show the output. So just I'll include that also, no problem. First, I'll put the X label and Y label and plot.show. So what is the output right now? Can you guess? Just I am giving the title X value. You'll get the empty graph.
X-axis it will show the experience, and Y-axis it will plot the salary.
Yes, ma'am. Very good. See, ma'am, here we'll get the empty graph, experience and salary. Right? We'll get the experience and salary. Right? So if you want to plot some value, right? What you have to do? You have to use the scatter. Good. You have to use the scatter. So here you can use the scatter. With the scatter, you can give the X train value and Y train. I can give the X data and Y data. I am taking this value.
70%.
Yeah, this one, this part I am taking. Okay. So now I run this program. So select this and shift enter. See the graph. The values whatever given here in my data set, right? Whatever value are given here, okay, 60 data are given here, okay, the values are plotted here. So you have to use the command function scatter. You have to use the function scatter, right? So next one, right? After that, if you want to plot the best fitted line, I told you whether we can draw the line, straight line in this way or here, how to draw that. Okay, so we know the concept, right? We have to calculate the sum of square error, right? What is the minimum sum of the square error that will take the data point, right? And plot the graph. So who will do all the job, right? Our algorithm will do all the job. Okay, so next one. See, if you want to plot the straight line, right? If you want to put the straight line, you can use plot. Scatter means just plot the points. Okay, if you want to do the regression, that is a straight line, you have to use the plot. Yeah, I'm using here X-train data, then a regress dot predict. Okay, so regress dot predict X-train. So already we fitted this X-train data in this previous statement here, already is trained. Okay, so this statement for training purpose. This statement for training purpose. Okay, that's why you can use the X-train, right? So what will happen here? I run this program. See the straight line. Okay, see the straight line here. If you want, you can copy and paste it in the Word also. Okay, so you can copy and paste in the Word also for analysis. So experience, salary, right? So this is a best fitted curve, right? So we have draw the graph for this this data only, right? Simple linear regression. So how do you draw the graph, visualize the graph based on the test data only? Okay, again, see here. I take this code. So here I have given the name simple linear regression. The next one, I change the title simple linear regression with test data. Okay. So here based on test data, here we have to plot the curve for the test data. Okay, this part, the training part. So test part. X test, comma Y test. Right. So I can make a differentiate. You can use the color red and blue. Right. Then plot. You can use the X test. Right. Regress dot predict X test color blue. Okay. Now I'll execute the program. If you want to execute the whole program at the same time, also we can execute. Okay. Here, I got the graph like this: simple linear expression regression with the test data only. Okay. So you can copy this graph and store it in the Word and compare the performance later on. Okay. What is the difference between these two? Okay. Similarly, if you want to take this graph, test data and train both. Okay, so first I give the simple linear expressions, okay, with the trained data. After that, I test data. Okay, after that, so you're combining both test data and trained data. How do you visualize the output? Here, you can visualize the output here, both trained data and test data. This is the code here. So for scatter, I'm using the test data. Right, for scattered, you can use the test data. For the slope, this is a straight line. Plot means it's a straight line. Okay, for the slope, I'm taking the trained data. Okay, I repeat one more time. For scatter means the plotted points, the plotted points. For this, I'm taking the test data. This graph combining both test data and trained data. Okay, for plotting the straight line, right, I'm taking the trained data. Okay, I'll execute this. Shift enter. See the graph. If you want, you can copy and paste in the Word. So compare the two graphs. You can compare the two graphs, test data and the trained data and test data. Okay, so almost similar. See here. So like this, if you want to do any project also, we can do like this. If you want to get the intercept point, right? If you want to, what is the intercept point? Regress dot intercept underscore. You can use print regress dot intercept underscore. Right? You can use this. If you want to get the shift under error underscore.
Underscore.
Yeah, it's not.
Please check the spelling of intercept also, sir.
Yeah, it's wrong, sir. Thank you.
Or missing.
Ma'am, now INTRCPT. Now it's correct, ma'am. Yeah.
Okay.
I got the value, intercept value. Okay. So if you want to get the coefficient also, you can get the coefficient. Print regress dot COEF underscore. Yes, you can get it. Okay. So any doubts so far, ma'am? Anybody, please?
No, sir.
If
Yeah,
you
it's
want,
very interesting example. And
so if you want to execute,
I have one question related.
Yes, sir, please.
Can we change the font size on x-axis values and y-axis values?
Different parameters are there.
Because when
right?
you copy that graph,
no, it is there. Okay, it may be there. I didn't check that. Okay, so all the options will be available. Okay, I'll take the main part only. Right. If you want to analyze in depth, you can take this code and analyze in depth.
Suppose we have x value that the column has 4, 5, something like that. How to plot?
Yeah, option is available, ma'am. But I forgot the syntax. Okay. Options also available. You can change that.
Okay.
You can check that.
For the given example,
Yeah.
hello sir, for the given example, how to calculate accuracy of the model?
Accuracy also, we have the some command, right now I didn't calculate here. We have the accuracy, right? Then that is a matrix also there, true positive, true negative, right? The precision value, recall value.
Confusion.
Yeah, everything's available in Python.
Yes, sir. Yes.
Yeah, so I didn't. Since we have a short period of time, I didn't execute all the parts in the one. Okay.
Okay, sir. Okay, sir.
I have one small request, if possible. Can you please share whatever
Yeah,
code
sure,
you
sir.
use
Sure,
for
sir.
this
Definitely.
example,
Definitely, I'll share.
so
Yeah,
that
yeah.
we can try out afterwards?
Yeah, sure, sir. Definitely.
Because this is very good example you explained in very nice manner. Thank you, sir.
Thank you, sir. Thank you. Okay. So suppose if you are executing the program in another one, Jupyter. So I'll give the introduction to you. Later on, you can try. Okay. So you can go to the. Is it visible, sir? My screen is visible.
Yes, it is visible.
Yes, sir.
It is visible.
Yes,
Yeah,
sir.
yeah,
Yes, sir.
You can select the Anaconda prompt here. You can
Okay.
click this one. Okay. So actually, in the desktop, I have stored everything. The desktop, right? So DS talk, right? So I stored here simple linear regression, right? I stored the simple linear. Under this, I stored the salary data, right? I go to this folder. It is available in desktop. Okay, I change this CD desktop, CD simple linear regression. I go to sorry. There's a folder name simple. Folder name is simple linear regression. Please check the spelling also. CD simple linear the problem.
It is there under DS talk.
Oh yes, correct. Okay. CD DS drop. CD simple linear regression. Yes. So now I can start the Jupyter. Start JUPYTER Jupyter notebook. I start my Jupyter. Whatever I have done here in the spider, okay, in the spider, if you want to run the whole program also, we can run at a time, right? If you want to run all the programs at a time, also we can run. This is the command here, the triangle shape, we can run completely will execute. Okay. So same program, could you run in the Jupyter environment? Okay. I'll give you some introduction, later on you can try. So here new, you have to use the Python. So it's a command window is coming, right? So here I can paste this. If you want to rename this file, you can rename here, right? So you can simple linear regression or something, whatever you want, you can give. So SLR2. Already I given some file. SLR2 I have given image. So I copy this in this prompt. Okay. So how will you run this? Shift, same thing, same command. Shift enter. If it is error will be displayed here. There is no error here. There is no error here. First part successfully completed. Second one, import the data set. How do you run in the Jupyter environment? Again, shift enter, successfully entered, successfully executed. So if you want to check the y-axis, just type the x and shift enter. Y-axis. If you want to check the y value, type the y and shift enter. You'll get the y value. Okay, whatever I stored here, that value will be displayed here. Right. So like this, we can run the program individually here in Spider environment also, Jupyter environment also. Shift enter. Like this, we can run one by one. Okay, so I continue or I stop from this. I'll go for other techniques.
Okay, sir.
Okay, so the idea is we can run in, yeah, the same thing. You can copy and paste it. I give the code to you. Just copy and paste it here. So how to build the model. Okay. So everything same. So I shift enter. Okay. So see here the linear regression. Okay. There is no, if it is error, suppose I miss something, right? Suppose I miss something, error will be displayed here. See here. If I miss something, error will be displayed here. This in the window itself. We can correct the error, then continue. This is one example. So please, I got the more examples also, but we cannot continue all the things in right now, right? If it is a, I told you, we can regression can be applied for one variable, the two variables. Okay, this is a single linear regression, right? If you applied for multiple values, right? Multiple values, then we call this a multiple linear regression, right? We call this a, for example, in the previous example, we have given the year of experience and salary. The other two variables are involved. Okay, this is we call this is called simple linear regression. We call SLR, simple linear regression. If the multiple values are involved, for example, height, right, age, then sex, then location. This is the input parameter. This is the input, right? The output will be height, weight. Sorry, weight. Okay, the output will be weight. Okay. So in that case, instead of the one input variable, we are giving the multiple input variable. You can give the multiple input variable, one output variable. So this we called as a multiple linear regression. Okay. So I have the code for this also. I'll give the handover to this ma'am. Okay, you can check this. The same concept only. Instead of one variable, you are giving the multiple variable. Okay. So I'll go for the other concepts. Bayesian classification, right? So we know that is one of the classification technique, right? It is based on the Bayes theorem. I don't want to discuss any derivatives of the statistical formula, right? I take the formula as it is, right? This is a formula for the Bayes theorem, right? In the statistical, we have the formula Bayes theorem. Okay, I take this formula for our classification, right? So here, X is a data samples, right? X is a data samples. H is the hypothesis. We call it a posterior probability. That means the class label. For example, I take the example and explain that. Okay. For example, it takes some computer company, right? The computer company wants to analyze whether the customer will, based on the past data, whether the customer will purchase the computer or not. Okay. The last column is the class label. I told you, right? Class label. The last one is the class label. This age is less than or equal to 30, high income group, there is no student, credit rating is fair, they will not buy the computer. In our company, in a particular company, industry or company, right? We have the computer store, right? We want to analyze that using the tool, right? Maybe based class, we want to analyze that. Okay. For the new customer, will based on the past experience, will purchase the computer or not in our company. Right, that is our idea, right? So this is the past data I collected. This we call the data samples. We call this a data sample, right? I have to take this data as it is. For explanation purpose, I given the small data, but practically we have to train the huge number of data, right? That's what we call a big data. right? We have to train the huge number of data, then only we'll get the more accuracy, right? So we have to train this data. I take the explanation, we take the training purpose, we take this data. If any new data comes, this is X is a sample, I told you, right? Any new data comes, I have to analyze that whether I am going to whether the customer going to purchase computer or not in our store or not. Okay, that is our idea. So here X is a new data sample, right? X is a new data sample. So C is a class label. C1 or C2 means in this example class label attribute, right? This is a category attribute. There are two class labels are there. Yes and no category only, right? Yes and no category only. So this is like C1 is a yes category. C2 is the no category, right? So the form, please understand that X, this is a hypothesis. This is a hypothesis whether the customer for the sample X will purchase or not. Thus we have to predict. That we have to predict. This is a formula here. X is a sample, right? Again, we are modifying the formula, right? Based on the classes. For example, we have the M classes. In our example, we have the two classes, yes and no category only, right? So I modify the formula instead of the H, right? I use the class label here. See I refers 1 to M, right? In our example, 2. I value is 2. I value is 2. Class label 1, class label 2, right? Okay. So since the P of X is constant for all the classes, right? So we are not considering this P of X value, right? We are considering the P of X, P of C probability of Ci by X equal to P of X divided by Ci into P of Ci. We take this formula for our navigation classification, right? This is the main formula, Bayes theorem formula. This is a hypothesis whether the customer for this sample will purchase the computer or not. Okay, so that's why I use the samples classes here, C1, C2. I modify the formula instead of H, I'm using the Ci. So I, in our example, it's a 2, right? So repeat one time, P of X is constant for all the classes, right? P of X by Ca, I take this formula for my evaluation. Okay. Right. So I'll take the example, then I'll come to this part. This is my training data. This is a data sample. This is my database. We have the two classes. The last attribute is a class label attribute. Bias computer is yes, one category. Class bias computer with no, another category. This is my testing data, right? I don't have any answer whether age group less than 30, income medium, student yes, credit fair, whether will purchase computer my store or not. I don't know, right? I have to analyze for the new sample. Okay, based on the past experience, I am analyzing the new sample. What I have to do that? Okay, see, we have to calculate P of Ci value separately. The formula is P of Ci we have to calculate, then P of X by Ci we have to calculate, then we have to multiply. Then we have to multiply for each sample. P of C1 we have to calculate separately. C1 is a yes, C2 no, but 2 times we have to calculate. See here. So P of Ci have to calculate. Ci means C1. For example, C1. C1 means what? Bias computer yes. So bias computer yes, you have to calculate. How many samples totally? So 1, 2, 3, 14 samples are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So overall we have the 14 samples, right? 14 samples. How many yes categories are there? Please count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 9. So 9 by 14. Similarly, P of C2. What is C2 here? C2 is a no. Bias computer no, right? So total samples are 14, right? 5 samples are no. 1, 2, 3, 4, 5. 5 samples are identified no, right? So I have calculated this part. This portion I have calculated. I have calculated this portion, right? Next, I have to calculate P of X by Ci. What is X here? X is a sample. X is a sample. There is a test data, right? So individually, I have to calculate. That's why we have given the formula here. X1 Ci into X2 dot Ci. So the meaning here is I have to calculate age less or equal to 30 and who yes category. and in medium S category. Student S and S category is 1. Everyone you have to calculate. See here, P of age equal to less or equal to this X symbol. X. What is C1? What is C1? C1 equal to S category. So bias compared to S. So totally S category is a 9, right? Totally S category is a 9, out of which less or equal to how much? You have to less or equal to 1. Sorry, S category only you have to calculate. So where is S category? This is not S. Less or equal to S. Here 1. Here 1. So 2 only, right? So am I audible? Process.
Yes, sir.
Right. So we have to calculate the S category. So 2 divided by 9. Okay. So this is the value. Similarly, I take the less or equal to C2 also. See, there are 2 samples, class labels, C1 and C2. So see, this is a C1, right? Similarly, the same sample, the X value sample, individually I have calculated, multiply. So that's why I given the formula. Individually I have to calculate, then multiply, right? I take these samples, I calculate the S category, right? I take this sample and calculate the no category, right? So no category is 5 and less or equal to 30. How many no category? 1, 2, any other? 3. Any other values? Yes, 3 by 5. Okay. Similarly, we have to calculate for medium. Same way we have to calculate the C1 value and C2 value. You have to calculate, right? And similarly, we have to calculate for student equal to S. We have to calculate C. Both class value you have to calculate, and credit rating fair. Okay, fair also we have to calculate both category. Right now, after calculating this, okay, this is my X value, right? This is my X value. Okay, this is my X value. Okay, so what I have to do? I have to multiply, right? S category separately, right? What is the meaning here? X sample. This is X sample, data sample divided by C1. C1 means price company S, right? Into P of C1, right? P of C1 S category. So that means P of X by computer equal to S into P of bias computer equal to S. We have to multiply these 2 values, right? So if I multiply these 2 values, I will get this value 0.028. Okay. Similarly, I take the sample X, C2 value, C2 is a no value, into P of C2, right? No value. I multiply these 2 values. I calculate this here P of X by Ci, and previously I calculate this one, this value 0.3557. I multiply these 2 value, I'll get 0.007. Okay, which is the highest value?
No.
Which is the highest value?
Highest is yes. Yes.
Yes. Okay. So now we can the model will assume that X belongs to bias computer. Yes. The customer for this sample will purchase the computer in our store. This is a prediction only, right? Will purchase the computer. This is a naive Bayesian classification. Any doubt in this? Professors?
No, sir.
So briefly, I'll explain another one, a priori algorithm. This is a association rule mining algorithm. This is association rule mining algorithm. So in this algorithm, we can predict that, right? What are the customers purchase the items together, right? What are the items purchased together? So in this way, we can analyze that. Okay. So mainly these techniques are useful for market basket analysis. The term we called as a market basket analysis. Okay. So which items are frequently purchased together by the customers? Okay. This way we can analyze that. Okay. So in this way we can increase the sales. We can use the association rule mining. We know that if you go to a supermarket, okay, so frequent visit, for example, 10 times I visited the supermarket. Okay. So if you purchase some branded butter, okay, next time the customer will the supermarket people will inform you. Okay, sir, so far you have purchased this item. So frequently purchase this one. Can you purchase like that? So instead of informing to the manager, okay, the software will inform you. Okay, So last time, based on the past experience, you purchase these items. Okay, why not you purchase these new items? Okay, the a priori algorithm. The two important algorithms used in the association rule mining: a priori algorithm, another is a FP growth algorithm. Okay, the two important algorithms we have. Okay, so a priori algorithm is used to mining the frequent item set for the Boolean association rules. Okay. So before seeing this part, right, we have to understand the concepts. Okay, for example, we have the x1, x2, x3 are the different items. So we have the item set, right? So instead of mentioning the bread, butter, right, I am using the I1, I2. Okay, I1, I2 like this, right? We have the list of items we stored in the item set. Okay, so we have that. We call it a D. D means the task relevant data. This means entire database we cannot take for analysis. We are taking the portion of data for analysis. That data we called as a task relevant data. That data we called as a task relevant data. Okay. So 1 second, please. Okay. So here, the set of items is referred to as the item set. Okay, so we have the set of items we purchase in the supermarket. Okay, these items we call as the item set, right? The item set contain the k items, right? The item set contains the k items. We called as a k item set. We called as a k item set. Okay, for example, computer and software, right? We called as a bread and butter. Okay, 2 item set, right? Another term we have to know that occurrence frequency. Occurrence frequency or frequency count. Okay, occurrence frequency or frequency count means number of transactions that contain the item set. Okay, I'll going to explain that. Okay, similarly, there are 2 terms are involved here: minimum support and minimum confidence. Okay, support and confidence are involved here. Okay, we have the formula for this. Support of A implies B equal to P of A union B. This is the formula we have. Similarly, for confidence, A implies B equal to P of probability of B by A. The formulas are available. Okay. Right. So how our association rules are mined from large databases? There are 2 techniques are there. First, we have to find the frequent item sets. Okay. Second one, we have to generate the strong association rules. Right. So what is a frequent item set? Okay. So what are the item set satisfies the minimum support, right? Item set satisfies the minimum support. We call it as a frequent item set. Okay. There are 2 steps are involved here, right? There are 2 steps are involved here: join step and prune step. Okay. So I'll explain these two steps here. Before that, we have to know the a priori property, right? If you take the any item set, the subset also frequent. So what is a frequent? The item set satisfies the minimum support threshold. Okay, so I'll give the example to clear. So I take the database, I take this the D. The meaning here is I'm not taking the whole database, right? I'm not taking the whole database. I'm taking the partial database. That's why I call this a task relevant data. So generally we call this a D. Okay, we have the 9 transactions in this, right? I consider the minimum support count, right, is 2. Okay, 22%, right? Is the minimum support, and minimum confidence threshold value I set the 70%, right? So how it works? Okay. So here the steps 1, we have to form the candidate item set. That means one item set. What are the one item set? How many items are there? Item 1, item 2, item 3, item 4, item 5. 5 items we have. Okay. So I take the one item set. Okay. How many occurrences are there? Okay. This we call the occurrence frequency, right? Or frequency count. How many times one occurs? 1, 2, 3, 4, right? How many times? 1, 2, 3, 4, 5, 6. 6 times, correct. So I2. So like that we have to count all the items, right? We have to, what is the minimum support count we have said? 2. Okay. So all the items satisfies the minimum support, right? All the items we are satisfying the minimum support count. So we can consider these candidate item set considered as a frequent item set. L1. Here L refers the frequent item sets. Okay. So all the items are satisfies the minimum support count. I'm taking all the items as a frequent item set. Okay, see here. Next, I have to form the two item set. How do you form? There are two steps are involved. Join step. Okay, another one is a prune step. I'll explain. Join step means item 1 self join with item 2. Item 1, same thing. Self join. See here. L1 self join with L1. Right? We can form. We have the L1 here. Is it? See L1 here. Self join with L1. What is our formula? I1 should not count. I1, I2, same thing. We'll get like this. I1, I2, I1, I3 will get the two item set. After a self join, we'll get the two item set. That is a candidate item set. Now we have to check the occurrence frequency for the two item set in the database. Okay, occurrence frequency. I1, I2 one time. I1, I2 second time. I1, I2 third time. I1, I2 fourth time. Like that, you have to calculate. Right. You have to give the support count. How many times it occurs? These two items together. You have to count here. Okay. So this item I3, I4 this is not available. I3, I4. See here. I3, I4 is not available. This is 0. Right. Okay. So now this is a candidate item set only. After that, we have to form the frequent item set. So what are the item sets? Satisfies the minimum support. What is the support count we are setting? 2. Okay. These items are not satisfied. We have to remove this. This we call the prune step. We got the prune step. What are the items are not satisfied the minimum support count? That items we have to remove. Okay, this is not satisfied. This item not satisfied. Here not satisfied. Here not satisfied. Okay, remaining after you have to form here. Okay, L2. So again, L2 gel join with L2. We'll get the 3 item set. Many items are available. Okay, so what is the property here? If I'm taking the 3 item set, the subset also must be frequent. What is mean frequent? The item set satisfies the minimum support count that we call as a frequent. Okay, so I consider from this after pruning we'll get these two data sets. I calculate the support count 2, right? The 2 also satisfies the minimum support. This is L3, right? After that again self join L3 self join to L3. We'll get the 4 item sets. We'll get the 4 item sets. What will get? I1, I2, I3, I5. Okay, I'll get the 4 item sets. Right. Yes, I1, I2, I3, I5. Right. So can you check the subset? I2, I3, I5 is not frequent. That means not satisfying the minimum support count. Okay. If the rule for the a priori is the subset also a frequent. Okay. So the subset is not frequent here. We have to stop the algorithm. Okay. I will take the four items here. Right. I take the subset is frequent or not. Okay, if the subset is not frequent, we have to stop the algorithm. So this is considered as a frequent item. So these items are purchased frequently. Okay. That's all. Again, have the another algorithm. So time is not available. Okay. So any doubts in this place?
No, sir. Excellent.
Okay, thank you very much. I'll give the slides to Dhanalakshmi ma'am. Okay, you can get it.
I also request you to share the codes that you use for the.
Yeah, sure, sir. Sure, sir. Definitely. I'll share.
Thank you, sir.
Thank you, sir. Thank you.
Thank you, sir. Thank you very much. Shall I wind up?
Yes, sir. Sir.
Excellent session, sir.
Yeah.
Very nice session.
Thank you. Thank you.
Enjoyed it.
Thank you. Thank you so much.
Yes, sir. Yes, sir. You have done an excellent job.
Yeah. Thank you. Ma'am, shall I stop or?
Yes, sir. You can stop the presentation.
Okay. Thank you. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.
Sir, thanks for spending your time for this ATAL session. So all the participants would have enjoyed your session. Please share your PPT and all the codes so that in the evening we can share it to all the participants. Thank you, sir.
Sure, ma'am. Sure. Thank you. Thank you. Thank you all. Yeah.
Dear participants, kindly fill the attendance form. Link is shared in the chat box. Next session will start at 2:30 p.m.